Okay, today we're going over 5.3 graphing radical functions. So on this warm-up, it wants us to match each function with its graph. So when we have an even root, that function is going to typically look like where it has a starting point and then moves off in one direction. Now, usually it moves off positively and to the right, but based on different transformations of the graph, it could be in a different direction. So I can tell by looking that the graph of the square root of x is either graph A or graph D. Now, the difference in graph A and graph D are how quickly they rise. So I know that A and D are going to go either with the square root of x or the fourth root of x because they're both even roots. Now, D rises faster than A does, and so that is going to have a square root. So it is going to be D, because if you look at it, it has a quicker rise. It shows more vertical growth. Now, the fourth root, because if you think about what a fourth root does to numbers, it makes them smaller. And so graph A has a slower rise, and that's why the fourth root is graph A. Now, both of these graphs have a domain of x is greater than or equal to 0, and a range of y is greater than or equal to 0. Okay, the other graphs obviously have to be graphs C and graph B. Those are what they look like when they are an odd root without having any major transformations such as reflections, rotations done to them. So the same logic applies to this one. In terms of the cube root has a lower root than the fifth root. So the cube root is going to have a faster rise. Think about what it does when you cube root a number. Like, for example, when you take the cube root of 27 versus the fifth root of 27. The cube root of 27 is a bigger value. So it should have a quicker rise. So if you see graph C right here, it rises quicker. It shows more vertical growth than graph B. So that is why the cube root is graph C and the fifth root is graph B. Now let's look at those. They have the same domain and range. So the domain on graph C is all real numbers. It goes forever to negative infinity all the way to positive infinity. And then the range is the same because although it doesn't look like it grows very quickly vertically, it does go forever from negative infinity to positive infinity. All right, so looking at this example of graphing radical functions. So it says to graph each function and identify the domain and range of each function. All right, so graphing the square root of 1/4 x. The first thing I'm going to do is just kind of get a mental image, and I know that a square root graph is going to look like this, and that the 1/4 is going to be a horizontal stretch by a factor of 4. Now for me, what I'm going to do is I'm going to go ahead. I know it wasn't moved left or right, so I know it starts at 0, 0. So I'm going to go ahead and start at 0, 0 and just make a quick table. So then if I plug in a couple more points, and I can use a calculator to get them, I can kind of find the direction it heads. For example, I could do 4 in my head. So think about the square root of 1/4 times 4. Well, 1/4 times 4 is 1, and the square root of 1 is 1. So it's going to be 4, 1. Now, if you wanted to get more specific, that's where you can use your calculator and find out that when you plug in 2, you get 0.7. And when you plug in 6, you get 1.2. But if we're having no calculator, then I would just do ones that work out nicely. And so that graph looks like this. Now, it also wants us to identify the domain and the range. So the domain of this graph, it starts at 0 and then it moves forever to the right. So the domain is x is greater than or equal to 0. And the range, it starts at 0 and then it goes up forever. So the range is y is greater than or equal to 0. If you did set notation, then you could do from 0 to infinity for both of those. Okay, looking at B, B says we want to graph this function. Take note that it is a cube root function. So I know in general, the odd roots are going to look more like this, but this one has had some transformations applied. So the first transformation this has had is this has a vertical stretch by a factor of 3. So that's going to make it stretch out vertically, which means like kind of a taller look to it. But then it also has that negative symbol, and that negative is going to be a reflection over the x-axis. So that means that it's going to come back this direction. So I like to have a visual in mind so that I can be, more confident of my answer, but also just have a better feeling of what the equation does. So if I were to do this, I know that at 0, it's 0. And the reason I know that is because the basic cube root of x goes through there, and it was not moved left, right, up, or down. So that's how I'm pretty confident, but I could check it mathematically. Now, if I want to get some points, if I do, let's say, -1 and +1, I can either use a calculator, or if I plug them in, the cube root of 1 is 1 times -3, and that's going to be, the cube root of 1 is 1 times -3, and that's going to be -3. And then if you plug in -1, the cube root of -1 is negative, times -3 is positive. So let's see what that looks like. -1 is up to 3, and over 1 is down to -3. Now, if you wanted to get some additional numbers using a calculator, you absolutely could. And that is going to give us kind of a good shape of our graph. I did personally go ahead and make a table and get some more points because I wasn't sure how quickly it was rising. And it just kind of helped me get a better view of it. All right. And then the domain is all real numbers, and the range are all real numbers. Okay. Now we're going to look at transformations of radical functions. So it says describe the transformation of f represented by g. And remember that we want to list our order in horizontal translations, stretches and shrinks, both vertical and horizontal, reflections, and then vertical translations. So horizontal translations. I see a horizontal translation represented inside the square root with x minus 3, and that means that it moves a horizontal translation, and it moves right 3. And then I see the +4 on the outside of the square root, and so that is going to be a vertical translation up 4. All right, let's do the same thing with the next one. So what I see here is I see that we have this negative symbol and the 8. So keep in mind, first is horizontal translations. There's not one of those. Then it stretches or shrinks. That 8 is a horizontal, and then remember that we're going to go ahead and it's going to be the reciprocal. So it's going to be a horizontal shrink by 1/8. And then the negative inside the cube root symbol is a reflection over the y-axis. All right, and so now we're going to take the description and write an actual equation. So we're going to be real careful about the order that they list things off in and doing each step one at a time, paying attention to when we distribute and when we don't. So it says, let the graph of G be a horizontal shrink by a factor of 1/6. I like to write that out using some function notation. So a horizontal shrink, that's inside, and it's the reciprocal, so it's multiplying times 6. So it's going to look like this. Then it's followed by a translation 3 units left. Okay, that is 3 units left is going to be x plus 3, and that's also on the inside. So I personally do them one at a time to make sure I don't miss any steps. So the first thing I'm going to do is I'm going to, g of x is my new function after the translation. I'm going to take the cube root of x, that's my equation, and then remember, I'm going to plug in 6x wherever there was an x. So in this case, the 6x gets plugged in for x. Now on the next one, I do the same thing, except I'm going to plug in x plus 3 wherever there's an x. So I'm going to take that equation and plug in x plus 3. So I have to watch because since I'm plugging it in and replacing the x with x plus 3, I need to distribute. So my final answer is g of x equals, and I'm going to distribute, so I'm going to have the the cube root of 6x plus 18. And that is going to be my equation for g of x. All right, let's try another one. So it says, let the graph of G be a horizontal stretch by a factor of 3. Okay, so what that's going to do is it's going to be a 1/3, because remember, horizontal, we use the reciprocal, and it's going to be inside the parentheses. And then 6 units to the right, that's x minus 6. So start with taking the equation, and we're going to take the 1/3 x, and we're going to plug it in instead of x. So that's pretty easy because we're just replacing x. There's no distributing. All right, so now on this next one, we're going to take and we're going to plug in the x minus 6 to the x. And remember, you're replacing the x with the x minus 6. So I am going to go ahead and distribute there. So my final equation will be cube root, and then 1/3 times x is 1/3 x, and 1/3 times negative 6 is minus 2. And that is our equation. Okay, example 4 says how to graph a parabola. And so on this equation, we have negative 1/5 y squared equals x. So if I go ahead and work on rewriting this to where y is by itself, the first thing I'm going to do is I'm going to multiply times negative 5. So I'll have y squared equals negative 5x. And then I'm going to go ahead and I'm going to square root the negative 5x. So I'm going to have y equals plus or minus the square root of negative 5x. Now, I can use a table to figure out what this is going to do, but I can also just use the fact that I know that when I have a parabola with a horizontal axis of symmetry, it's going to look like either this pointing to the right or the opposite pointing to the left. So I can use some facts about transformations to try to narrow this down. So when I look at this, if it is y equals plus minus the square root of negative 5x, let's talk about it. The negative is going to be a reflection over the y-axis. So that negative right there by the 5, that's going to cause this to open left. Now, the only thing that's going to affect the vertex are going to be horizontal or vertical translations, meaning adding or subtracting. And none of that happens, so that tells me that the vertex is going to be at 0, 0, which I could check using a table and plugging points in. I could absolutely get there. Okay, so then I'm going to have to only plug in negative values, which makes sense because I do know that if it's starting at 0, 0 and opening left, the x values are negative. But it also makes sense because I have a negative 5x under the square root. So if I plug in negatives, a negative times a negative is positive, and that's why this is going to work. So if I plug in negative 1, I can plug it in, and I have the square root of negative 5 times negative 1. So that's going to be the square root of 5, which is a decimal. It's about roughly 2.2. So it's going to equal 2.2 and negative 2.2. So I can get there, and that's probably good enough just to get me a visual. I could continue on if needed, but I'm pretty confident of it opening to the left, being at 0, 0, and about how it is stretched out. So that 5 is a horizontal shrink by 1/5, which is what's making it so tall. All right, so graphing a circle, I would just go ahead, we've learned this in geometry, and when it's just x squared plus y squared, the center is at 0, 0, and then this 49 is the radius squared. So this tells me that the center is at 0, 0 because it's just x squared, y squared. If it was x minus 4 squared or y plus 8 squared, that would change it, but we're not going to see that today. And then the radius is the square root of 49, so the radius is 7. So what that means is your center is at 0, and you go up 7, right 7, down 7, and left 7, and then you draw your circle in. And then your intercepts, your x-intercepts are at negative 7 and positive 7, and your y-intercepts are at negative 7 and positive 7. So circles are pretty easy to do. Not to draw, though. Okay, I felt like number 1 on the monitoring progress was valuable to go ahead and get one more practice in. So to get y squared by itself, I could divide by negative 4. I could also multiply times negative 1/4, which in this case I'm going to do because I just feel like it let me see the transformations better. Then I'm going to square root, and so I'm going to get y equals, I'm going to have plus or minus the square root of negative 1/4 times x plus 1. What that does is, first of all, it lets me see that there is a horizontal translation left 1. That horizontal translation left 1 makes my vertex be at negative 1, 0. It also lets me see with the negative in front of the 1/4 that there is a reflection over the y-axis, which lets me know that it opens left. And then I can go ahead and use a table and plug in other points, such as negative 5, to find out that at negative 5 it's at 1, negative 1. That gives me enough to draw in my parabola.